This is the review for exam 4, which is chapter 5, the mathematics of finance. And the first problem we have is to find the compound amount for the loan of $57,809.34 at 6% compounded quarterly for 5 years. The compound amount is the same as the future value. So it is the future value that we will solve for. The compound amount is all of the payment made, which is the present value, plus all of the interest that that payment actually earned. To solve this problem, we will use the TVM solver on the calculator. N represents the number of payments. Since the payment amount and the compounding, or the payment times and the compounding times are going to have to match, that's going to be 4 because it is compounded quarterly for 5 years. So that means there will be 20 payments at a 6% interest rate, and the amount that is put in the beginning, which is your present value, is your $57,809.34. We won't make any further payments, so we'll enter a 0. Payments, if there were any, would have been made at the end, but basically we leave this set at the end because the only time we have payments made at the beginning of any kind of finance formula is when we have an annuity due, and this is not an annuity. So we enter those values into the calculator. N equals 20. Interest is equal to 6. Present value is 57,809.34. The payment amount is 0. We will enter 0 for the future value, and then payments per year and compoundings per year both will be 4. And then we will solve for the future value. And the future value of this loan is 77, or this investment, it's not a loan, $77,860, and 79.799 would round to 80 cents. And keep in mind, compound amount means all of the interest plus the initial money paid in, so that is the same as future value. Our next problem wants us to find the amount of interest earned on an investment of $34,677.23 at 4.8% compounded monthly for 32 months. That means there will be 32 payments. N is 32, and compounded monthly means 12 times a year. And once again, there are no payments, and we don't worry about that last line. We will solve for the future value because we need the future value minus the initial investment to find out how much the interest is going to be. So entering this information into the calculator, N is 32, interest is 4.8, present value is 34,677.23, 0 for the payments, 12 times a year for payments and for compounding, and solve for the future value. And the future value is 39,000 $402, and 0.448 is 45 cents. So from the future value, we will subtract the present value, which is $34,677.23, and this will give us the interest. So 39,402.45 minus $34,677.23 is $4,725.22. In this problem, we're going to find the present value. So at the present value, that's where we're going to place the solve. 42,000 in 7 years indicates to us that that is a future value. So the future value is $42,000. And since it's compounded monthly, then that's going to be 7 years times 12 months a year gives us n is equal to 84 payments and compoundings at an interest rate of 6% with no additional payments, because we only have the future value and we're looking for the present value that would have been deposited to yield that future value. And again, compounded monthly means CY and PY are both 12 and at the end of each month. So again, going to the TVM solver, n is equal to 84, I is equal to 6. We'll start out with the present value of 0 and then solve for it. 0 for the payment. 42,000 is our future value. And put in your payments, compoundings, and your payments are at the end. Solve for present value. And the present value would be $24,624.86. So if you deposited $24,624.86 today at that interest rate and left it for 84 months, then this would be how you would have $42,000 in 7 years. Problem number 4 wants us again to find the future value, but it also wants us to find the amount of interest earned. So that means we're going to have to find that future value and then subtract the total amount of the payments. And it says that the payments are $1,288 each year for 14 years. So that will be a total of $18,032. And now we need to solve for the future value. So for n, we enter 14 because we're depositing at the end of the year for 14 years at 4%, compounded annually, which means P/Y and C/Y are both going to be 1. Our present value will be 0, and our payment amounts are $1,288. And we will enter a 0 for the future value and then solve. And when we solve for the future value, we see that the future value is $23,559.98. So the future value minus the total of the payments $23,559.98 minus $18,000.32 gives us the amount of interest. And the amount of interest is $5,527.98. So again, this is our future value, and this is the amount of interest that we earned, because $18,032 was our money that we put in deposits. Question number 5 is $11,900, which is a lump sum payment each month. So we're going to be compounding monthly for 13 months. So that means the number of payments we're going to make is 13. The compoundings monthly means the payments per year is 12. The compoundings per year is 12. The interest rate is 6. And again, this is going to be for 13 payments. That's 12 months plus one payment. We don't know about the present value because we are interested in finding out what the future value is. So we're going to solve for the future value. And the thing to be sure of is, because this is at the beginning of each month, our payments have to be set in the TVM solver to be at begin. So N is 13, interest rate is 6, each payment is $11,900, present value is 0. We'll enter a 0 for the future value. P/Y and C/Y are both 12. Change the bottom line to say begin, because it's an annuity due because payments are made at the beginning. And then let's go back and solve for the future value. And the future value is $160,000. $224.29. And this is the future value of an annuity due. And it's an annuity due because payments are made at the beginning. If it was an ordinary annuity, your payments are at the beginning, or I'm sorry, at the end. So keep that in mind, because that's a question you may see on the exam. Question number 6 says give examples of two types of loans that are commonly amortized. And that key word there is amortized. And what amortization means is that you borrow a sum of money. That's the principal. That's cash inflow to you. And that money is going to be repaid with monthly payments. A mortgage is always monthly payments plus interest is charged on the balance owed at the time of each payment until the sum that was borrowed is completely repaid, making the future value of this mortgage 0. And the interest charged at the end of each month is also completely paid. Commonly, this is the type of loan used to finance a home, which is why you hear people talking about they have a mortgage, and some people have a second mortgage, meaning that they've borrowed money twice on the same piece of property, or to purchase a car, although you can amortize a loan as well. For example, if you take out a loan to pay for startup costs for a business, or for some project, or for a vacation, those are all mortgages, even though they don't involve a house, because the key idea is that you borrow a sum of money and then repay it with monthly payments and pay interest on the balance out of that payment every single month. Question 7 says, what's meant by the future value of an annuity? Future value tells you what is going to happen at the end of the annuity. And since we know the purpose of an annuity is to deposit money into an account and save it so that you'll have the money you deposited plus the interest on it, then the future value of an annuity is the sum of all the payments made to the annuity plus all the interest earned on those payments throughout the life of the annuity. And once again, if that annuity is an ordinary annuity, then your payments are at the end of each period. Whereas if it is an annuity due, your payments are made at the beginning. And a key piece of information here is to remember that the annuity due, actually, if you have the same amount of payments, if each of your payment amounts is the same, the annuity due is going to actually have the larger future value. And the reason for that is because you get interest on every single payment you make, because you make that first payment at the beginning of the first payment period. And that one payment draws interest through every year of the annuity. Whereas in an ordinary annuity, your first payment gathers no interest, and then your last payment only gathers 1 month's worth of interest. Now, 1 month's worth of interest, your last payment in the annuity due gains no interest. That is far outweighed by the fact that your very first payment gathered interest throughout the life of the annuity. Number 8 says that we are considering something called a sinking fund. Keep in mind that if what you have is a sinking fund, the purpose of a sinking fund is to save money for some specific purpose. And in this case, the annuity, the sinking fund, has a value of $233,188 for some future project. But keep in mind that is the future value. The amount given for a sinking fund when you're trying to find those payments is how much money do you need in the future. And then, of course, money earns 5.2% compounded quarterly for 7 3/4 years, which I use 7.75, and 7.75 times 4 payments a year means that there's going to be 31 payments and compoundings. And of course, this is going to be, again, at the end of the period, so don't forget to change your TVM solver. If you have used it, you need to change that back to the payment being at the end. So on the TVM solver, we enter 31 because 7.75 times 4 is 31. The interest rate is 5.2. Your present value is 0 because you do not make a lump sum deposit one time and walk away. You make periodic payments. The payment is not something that we know, so we enter a 0 for that. And we know that in the future, we're going to need $233,188 for FV. And compounded quarterly, We need 4 in C/Y and P/Y, and payments are at the end. So solving for the payment, we see that the payments necessary to do this would be $6,156.14. Number 9 asks us to find the present value. If they've asked us to find the present value, then they have to either give us payments or the future value. They're going to give us payments of $4,210, compounded semi-annually, which means twice a year, for 8 years. So 8 times twice a year means there will be 16 payments at 4.2% compounded semi-annually. Our payments are going to be made at the end, and what we want to know is, and basically when they ask you what is the present value of this annuity, the present value is how much could we deposit today? To have the same amount for future value as if we made these payments. So that's really the question that we're answering. So again, we'll enter the information in. N is equal to 16. Interest rate is 4.2. Present value we will solve for. The payment is $4,210. The future value is actually not of any interest to us, so we're going to enter a 0. And compounded semi-annually means PY and CY are both 2, and payments are again at the end. So the present value would be $56,711.93. So we could deposit $56,711.93 right now today and walk away, make no further payments, and have the same amount of money at the end of time as if we deposited that $4,210 16 times. And if we actually took the payment route, then in order to have the same future value, we would be actually depositing $67,000, $67,360, and that's the total of the payments. And this is the lump sum. Of course, the catch is you may not have this much money up front, but even though this is a lot more money coming out of your pockets, you may have $4,210 twice a year to be able to deposit, rather than being able to put in over $56,000 right now. Next problem is about a mortgage payment. Keep in mind when we're talking about mortgage payments that mortgages are always monthly. Monthly payments, monthly compoundings. So 12 payments a year and compounded interest 12 times a year. So over the course of 30 years, you're going to make 360 payments, and your interest will be compounded 360 times. Your interest rate is 6.45%, and the amount that you borrow to purchase the house, so this is cash inflow to you, is $253,000. At the end, you want the future value to be zero because you want to have paid off the house. So what we need to know is how much is each month's payment going to be. So we enter the information, 360 for N, 6.45 for the interest rate. You're borrowing $253,000. And the payment is what we want to solve for, so we enter a 0 for that and for the future value. Compounding and payments 12 times a year. So when we solve for the payment amount, our payments are $1,590 and 82 cents. So in number 11, we're talking about business financing. And the information we're given is that this business borrows $48,000. That's cash inflow to them today. So that is the present value of a loan. The money is going to be repaid in equal payments, but they're only going to pay those payments at the end of each year for 7 years. So this is not a mortgage because there's no monthly payments. So they're going to make 7 payments, one at the end of each of 7 years, which means the number of payments is 7. Payments per year and compoundings per year is going to be 1. At the end, the loan is going to be paid off. So the future value would be 0. The only thing that we need to figure out is how much is the payment amount. So we'll enter the information. 6.5, 48,000, positive because it's cash inflow. 0 for payment, 0 for future value, once a year for PY, once a year for CY, payments made at the end, and we need to know the amount of each payment, so we solve for payments, and the payments are going to be $8,751 and 91 cents times 7. So the total amount of the payments is actually going to be $61,263 and 37 cents. And from that, we're going to subtract the present value, or the amount of the money we got out of the loan and will repay in the loan. So the amount of interest that we will have paid to borrow that $48,000 is $13,263 and 37 cents. When you have these problems, be sure to read carefully because this required 2 answers: the amount of each payment, which is this, and the total amount of interest paid, which is this. Be sure to answer both questions. Number 12 gives you a comparison of two different financing methods for a car. In the first method, the first offer was for 0% financing for 60 months. So 0 interest rate for 60 months. And once the buyer chose that offer, they still needed to finance $20,000 for the 60 months to buy the car. So that's cash inflow to them to buy the car, and they're going to have to make payments to repay the loan. The future value of the loan, of course, you need that to be 0 because you want the car to be yours and it needs to be paid off. You're going to make monthly payments, and you're going to pay at the end of each month. So the payment amounts, and if you think about this logically, the payment amount should be, since there is no interest, each payment should be $20,000 divided by the 60 payments. Which is $333.33. But even if you don't think about it that way, you can still use your TBM solver the way that I set it up. 60 payments, 0% interest rate, $20,000 for your present value. Solve for your payment amount with PY and CY both being 12. And that is exactly what you get. $333.33. But the thing to be cautious of here is says to find the total amount the buyer paid for that option. So what the buyer paid was the total of $20,000 for the car, which is the 60 payments of $333.33 each. They paid $20,000, but they got a bonus in cash of $1,500. So that was not money they paid. That was money they gained. So when you take that from the $20,000, that means what they actually paid for that car in total was $18,500. Now, Part B of this is a different offer. Is less than the $18,500 they paid for the first option, even though it was 0% interest. In Part B, the second offer is you get $3,500 cash back. So remember that. The second offer, this buyer needed to only finance $18,000, not $20,000, because they got $2,000 more in cash back. So they financed $18,000. They were able to get a new car loan at 2.69% interest. And they financed it once again for 60 months, 12 payments, and interest compounded 12 times a year, with the goal being that the car is paid off at the end, and we need a payment amount. So we're going to enter that information into the calculator. Interest rate 2.69. Amount borrowed is $18,000. Payment's what we're going to solve for. And their payments are $320.96 each. And we're going to multiply that amount times 60. And the total amount they repaid then is $19,250. $257.60, but keep in mind that they still got the $3,500 cash back. So their actual cash outflow for this was $15,757.60. So looking backward, the total amount they paid, $15,757.60. And then our last two problems are about buying and selling a house. First thing we're interested in is that, they bought the house and the asking price was $191,000. Generally, you do not finance the entire asking price. So they paid $40,000 down, and what they actually borrowed then was $151,000. They took a 30-year mortgage, and remember, mortgages are paid monthly. And for 30 years times 12 payments a year, that's a total of 360 payments. So our number of payments is 360 at a 6.5% interest rate. And they borrowed $151,000, which is your present value. Future value is going to be 0 because we want the house paid off, and we're going to solve to get their payment. So the amount of their monthly payment is $954.42. The second question, because this was only part A, how much of the first payment was paid in interest? Because this did not all go toward reducing the debt. Some of it went toward interest. And the way you calculate that interest on that first payment is for 30 days or 1 month, they were being charged interest on $151,000 at a rate of 6.5% for 1 month. This is actually your simple interest formula. Your monthly interest is simple interest. So interest is equal to the balance of the loan, which is P, times the interest rate R, times the time measured in years, and 1 month is 1/12 of a year. And that means that $817.92 of their payment actually went to reduction of the debt. So $954.42 minus that $817.92 means that of this whole $954.42 payment, only $136.50 went toward reducing the debt. So that's the end of the review, and we will upload this review to YouTube, and if you have questions, please let me know.